Hello friends, I am NK Jain from Skill on Tech. I am presenting a series of video on 200 interview questions on pumps. The videos shall be very interesting to upgrade your knowledge on pumps. Question 1. What is head? Head is a height of liquid in container. Head is a term for expressing meter of water column. Head can also be converted to pressure. So you can see in this picture that this is a 20-meter water column. So this 20-meter water column will be equal to 2 kgf per centimeter square gauge pressure. So this pressure will be exerted here by the mass of this column. What is flow and pressure? Flow, if mass or volume of liquid flowing per unit time, is called flow. Flow can be expressed as meter per cube per second, meter cube per hour in units. Flow can be internal or in pipeline. Pressure is a resistance to flow. If a liquid is flowing in confined space, it will develop pressure per unit cross-sectional area. It can be expressed as kgf per centimeter square, Newton per meter square, bar or Pascal. These are the units of pressure. Head and pressure are interchangeable terms provided that they are expressed in their correct units. The conversion of all pressure terms into units of equivalent head simplifies most pump calculations. Question 3. What is difference between flow, pressure and head? You can see a picture where flow in open channel or river is shown and a flow through pipe is also shown. Head is a height of liquid column irrespective of its shape in the container or shape of container, because liquid takes shape as per the container shape. Pressure is a force exerted by liquid column in the bottom surface of vessel or pipeline per unit cross-sectional area. Flow is expressed volume of liquid gas flowing per unit time. The relation between pressure and head is expressed as P equal to rho gh, where P denotes pressure kgf per centimeter square, rho is density of liquid, and h is head of liquid column in meter. Question 4. Why pump is required? Liquid is a mass. The mass cannot be moved or flow without adding energy as per first law of motion equation. If we intend to transfer liquid or gas from one point to other point, we need energy. Energy is added in liquid with the help of pump. In case of transfer of gases, we use compressors. Hence, for transferring liquid from one place to another place or higher elevation, we require pumps with operating energy that may be manual or in other forms such as electrical energy or energy from diesel, petrol or solar. Question number 5. What is priming in pump? You can see a picture of a pump. The pump sometimes not discharge flow. The problem is entering of air in suction pipeline of pump, including casing, while pump rotates. It compressed air and not develop pressure as air is compressed in the casing of the pump. You can see in this picture, this is a suction pipeline from where water is to be lifted, and this will go here. In case if air bubbles are there in the suction pipeline, then they will be sucked, and here also this air will be compressed continuously. So if air will be compressed, water cannot be entered. Where negative suction in the pumps, so here you can see this is atmospheric pressure, and here in the casing of the pump, here it will be zero pressure. So the water can be lifted up to a height of maximum equal to atmospheric pressure head, that is equal to atmospheric pressure is 1.03 kg per centimeter square and equal to 10.3 meters of water column. So generally pump can suck water from 7 to 8 meters depth. So until air is compressed in the casing of the pump, during operation of the pump, water will not be lifted. So removal of air is compulsory from the pump casing and suction pipeline. Generally pumps are equipped with footwall, but in case it is not equipped with the footwall, then air will be there in the suction line and casing. Hence water is filled from discharge pipeline to remove air. In normal conditions, common centrifugal pumps are unable to evacuate the air from an inlet line, leading to a fluid level whose geodetic altitude is below that of the pump, as shown in the picture. Self-priming pumps have to be capable of evacuating air from the pump suction line without any external auxiliary devices. In the self-priming pumps, there are two chambers in the casing of the pump. So one chamber is always kept full of water. So it will develop pressure and pump will give starting flow. Question 6. From how much depth a pump can lift liquid? We have also discussed net positive suction lift head is defined by the net inlet head and the difference between head equivalent to vapor pressure of liquid to be pumped. This is also called net positive suction lift head NPSH required. So you can see in this picture, this is a suction resistance. So suction resistance is a part of friction head in the pipeline and a velocity head, this much. And this is a net suction head, means this is a lift because this is a water level here. So this is a suction lift. And this is a net discharge head, this one. And this is a resistance in the discharge head. So we require this gross pumping head, this one, this HD. So this gross pumping head will be provided by adding energy through motor to the pump. But initially for sucking a water from the net suction head, pump manufacturers provided NPSH required. So always pump must be installed with NPSH available, always more than NPSH required. But in case of water, atmospheric pressure is 1.0332 kg per centimeter square. That is equal to 10.3 meters of water head. So we are taking an example of water from how much depth pump can lift water. So theoretically 10.3 meters minus vapor pressure head, as we discussed in the earlier diagram, lift is possible. But there are frictional losses in pipeline and head equivalent to frictional losses is also required to be deducted from total lift of 10.3 meter. So vapor pressure of water at 20 degrees centigrade is approximately 2.3 meter of water column. Assume frictional losses of 1 meter head in the suction lift. So the pump can lift water from negative suction is maximum 10.3 minus 2.3 minus 1, that is equal to 7 meters of depth. So generally a pump can lift water from a negative suction is 7 meters depth. If we will install a pump providing a suction lift more than 7 meters, then your pump will not lift water. Question 7. Why cavitation occur in the pump? You can see a picture of a pump and a graph of a pressure. Cavitation occurs in a pump when the temperature and pressure of the liquid at the suction of the impeller equals to vapor pressure. Here, in this suction, if your suction pressure at impeller I equal to vapor pressure of the liquid, then it can happen at low pressure and normal operating temperatures and will start creating bubble formation. You can see in this picture the suction pressure is goes down. So here it is a vapor pressure. So if it comes below this, then your liquid will start in the formation of bubbles. So these bubbles when travel to discharge side will collapse. Locally it results in the liquid turning to a vapor and creating very high temperature and pressures. Bubbles form during cavitation. As the pressure in the pump increases, those bubbles collapse in the form of an implosion equally as violent as an explosion. The implosion causes shock wave to travel through the liquid and hit the impeller, causing mechanical damage. Here in this picture you can see from here liquid will enter. If suction pressure comes equal to vapor pressure of the liquid, then here this bubble formation will start, and at the discharge side of this impeller they will collapse and hit the impeller and will get it damage and erode. Question 8. What are hazard of pump cavitation? The cavitation occurrence in pump damage the impeller and casing of the pump. You can see a picture of impeller where this impeller is damaged due to cavitation. Under the condition favoring cavitation, vapor bubbles are seeded by surface defects on metal components within the pump. For example, the impeller of a centrifugal pump or the piston or gear of a positive displacement. When the bubbles are subjected to high pressure at discharge, they implode energetically, directing intense and highly focused shock waves as high as 10,000 megapascal at the metal surface on which the bubbles had nucleated. Since the bubbles preferentially form on tiny imperfections, more erosion occurs at these points. Question 9. How you will know that pump is cavitating? Decrease flow or pressure. If your pump is not producing the amount of flow as stated by the manufacturer, this could mean that cavitation is occurring in the pump. Unexpected vibrations. Cavitation can cause unusual vibrations not accounted for by both the equipment used and the liquid being pumped. Impeller erosion. Pieces of impeller within the system or eroded parts are a sure fire sign of cavitation. Seal bearing failure. Cavitation can also cause the seal to leak or fail due to high vibrations in the pump. Erratic power consumption. If bubbles are forming around the impeller or the impeller itself has already started to fail, you may notice that your pump requires more power than usual to transport its media. You may also notice fluctuations of power used as suction rises and falls depending on how the impeller is performing. Noise. If there is one sign of cavitation, it is noise. When the bubbles implode, they can make a series of bubbling, cracking sounds. Alternatively, it might sound like tiny marbles or ball bearings rattling around inside the impeller housing. Question 10. Your pump is vibrating. What may be possible reasons? This is a very common problem in the pumps. Imbalance in rotating components, misalignment of motor and pump, defective and inappropriate bearings, process fluid leakages, weak foundations, loose structures and suction discharge piping. NPSH available is less than NPSH required. So these are some common reasons by that pump generally gets vibrating. Vibration is a big enemy for pumps because if vibrations are above the permissible limit of vibrations, then your pump can be damaged very fast. Thanks for watching the video. If you like this video, hit like button below, share it with your friends and colleagues, subscribe our channel for getting updates on upcoming videos. Please leave any comments, feedback to improve the videos. Thank you.